Hi, I'm Mandy Hubbard. I'm a software engineer and a QA architect from Austin, Texas. I'm currently working for Ship Engine, which provides the world's greatest shipping API to connect carriers and marketplaces and allow smaller businesses to kind of compete with larger businesses. And I work there ensuring quality, building CI/CD platforms, and it's my love for quality that really brought me to Jenkins. I spent a lot of time working for companies from fintech to big data. And a lot of the times we were doing testing after the fact and we didn't have really solid release processes. And once I learned about continuous integration and development, I recognized that was a key part of ensuring quality delivery that we had missed. So all of that is to say, I love Jenkins and I'm excited to be here today to share with you some of the things that I've learned along the way. So let's get started. So today, I'm going to talk to you kind of about the way in which we develop software has changed over the years and how it continues to change. We'll talk a little bit about what we're looking for when companies talk about moving to microservices. We'll talk about those promises that microservices are intended to bring and talk about what that means for our CI/CD environment. And then finally, that's going to culminate in my journey to Kubernetes, and I'll show you how I got Jenkins running in Kubernetes, and also talk you through some of the things that I tried in the past before evolving my platform to Kubernetes. So back when I started my software engineering career, things were pretty simple. We had a monolithic application. It usually ran on a single server. The database, the identity management system, everything was all in place on one server. And that greatly simplified the way that we built, deployed, and tested software. As we move forward, we started having distributed applications. So perhaps we would put our database in its own environment, on its own server, and maybe we would move sort of individual pieces onto different servers, but we still had a very few number of actual pieces of infrastructure. Created some new challenges to building and deploying and testing software, but we're still pretty small in terms of the number of moving parts. But now today, as we are moving things to the cloud and trying to really isolate small pieces of functionality into microservices, the way we build and deploy software has changed dramatically. I know you've seen this slide before. We've heard all of these great promises of microservices. Everyone is moving, it's the new hotness. We want to deploy small services independently and reduce some of our dependencies. We want to be able to make small, isolated units of change, which is going to reduce risk, and be able to scale horizontally and more granularly. And most importantly, moving to microservices allows us to use the best tools for each task. We really no longer feel as compelled to consolidate over a single technology or language because we have all of these individual services that allow us to use the right tool for the job. So the big promises here result in a reduced cost and a reduced risk. And what company doesn't want those? Now, when we move to microservices, this is drastically going to change the number of builds that we produce. So I want to take a minute, and if you've ever seen me speak before, I pretty much always use this slide because it's one of my favorites, and I think it really illustrates what it means to be running a true continuous integration and a true continuous delivery environment. So the diagram at the top of the page depicts the process of creating new code and merging it into the master branch. In this example, of course, we're using Jenkins for our build and test platform, and we're using GitHub for our source control management system. So in this slide, we've got a developer who creates a branch to fix a bug or creates a short-lived feature branch to introduce new functionality and produces that on his or her local machine. When that code is ready, has been tested locally, and that developer is ready to merge that code and get it deployed, in GitHub speak, we open what's called a pull request, or more commonly known as a PR. This is going to send a notification to Jenkins via webhooks, where Jenkins will then understand that we've had a pull request open. Jenkins is going to build and test that software and then report the status back to GitHub. And this really hits home for me because this ensures that developers aren't able to merge those pull requests until all the tests have passed. While this is happening, this is what your repository looks like in GitHub. This is the pull request screen. And as you can see, I've got yellow for my status checks. My update branch button is disabled and my squash and merge button is disabled. So by setting up webhooks between GitHub and Jenkins and configuring settings in GitHub to say only allow merging once tests have passed, we've got an end-to-end loop so that PRs are automatically built and tested in Jenkins. So that's one build. Now, if the tests are successful, we go to this next screen. We now have green marks for our status checks. We don't have any conflicts, and the button is available so that we can squash and merge that into our master branch, which is the branch from which we deploy to production. Once the button is clicked, we kick off this process. GitHub is going to send another notification to Jenkins indicating that there was a push to the master branch. And the way we construct our pipeline scripts, we are able to put conditional logic in there to know to take different actions, whether or not we're building a pull request or we actually have received a merge to master. Jenkins will then build and test again, and then we deploy. And that gets into some nuances between continuous deployment and continuous delivery. The time at which you deploy and the environment to which you deploy, whether it's a staging environment for further testing or directly to production, that's really what's going to determine whether you're doing continuous deployment or continuous delivery. So the reason I want to show you this slide is if you consider the previous slide with all of the many services that make up an application when we're doing a microservices architecture, and then consider the fact that we're making very small changes in building. So these are frequent builds for a large number of services, and we're automatically building the pull request, and then we're automatically building again when we merge to master. So we've got an increased number of services, an increased number of daily changes, and at least 2 builds per change. So microservices plus continuous integration and continuous deployment or delivery, it gets us to a whole lot of builds. So the way in which we built and deployed our software in the past when we had a single monolithic environment has to change. So once we change the way in which we build software, we're going to change the way in which we run our continuous integration and delivery environment. So when you're building a monolith, you can get away with having a single Jenkins master, and despite the fact that it's really not the recommended way to run Jenkins, you can build on Jenkins for a while. You can build on the Jenkins master for a while. With a monolith, you have a consistent set of tools. Everything's kind of homogeneous. You're building a lot less frequently because you're doing, quarterly releases and things like that. And CLI is really helpful, but at that point, it's still kind of optional. We move to distributed applications. We may have a distributed build environment. We're going to be looking at needing to have more agents to run our builds. We potentially are building applications or pieces of the application that are written in different languages. And at this point, CI is not really optional anymore. But then when we move to microservices, we need multiple agents because we're building so frequently. We definitely are going to have different tools and languages to support, and possibly just different versions of the same language. And once we have moved to microservices, in order to achieve all of those benefits, to be able to release small changes frequently, independently, we have to evolve our Jenkins environment. So what I want to walk you through next is the evolution of my Jenkins agents. Like a lot of you, when I got started with Jenkins, I built a Jenkins master and I could execute all of my builds there, and it was the greatest thing I had ever done because everything was automated. And that worked really well for a while until I started trying to have all the dependencies installed on the master for all of the possible builds and then manage multiple builds running at the same time. So as we grew into more and more services, I created a single agent that had all of the tools I needed to build any of my services. Then if I needed to then if I needed to scale that agent, I just replicated that single agent with all of the tools. So I had a really bloated agent that did all of the work. And if I needed more agents, I just created a copy of the current agent until I had a lot of agents with a lot of tools that needed to be kept up to date. And that was really a maintenance problem. So the next thing I tried is I said, well, what if I create individual agents? I'll have an agent that has all of the tool chain I need to build my Go applications. I'll have another one that I can use to build Python applications, and another one that can build Java, and I'll just have a single agent for every single type of application I'm running. And then I won't have to manage, the versions of every single software, the versions of every single language across the multiple agents. But then you end up with a lot of idle agents. If you've got an agent for your Go app, your Python app, whatever languages you need to support, or whatever versions of languages you need to support. Let's say you're primarily releasing the Java application and you've got these other agents sitting by for when you're ready to release your Go or your Python applications. You've got a lot of idle agents. And if you're running these agents in the cloud, that's a lot of money that you're spending for agents that aren't doing any work. So I decided to evolve again to try to reduce that waste. So then I attempted multiple ways of Dockerizing Jenkins agents. And that was very revolutionary for the way that I was creating pipeline scripts and building using Jenkins. The first thing I tried was Docker and Docker. That's where you're running the Docker machine inside your Jenkins agent. And my agents are already Dockerized, but I need to build more Docker images for my production images that I'm going to be deploying. So I need to run the Docker machine inside of my Jenkins agent. And then I read about security risk and things like that. And I tried mounting the Docker socket of my Jenkins master inside my Docker agents. And I did that for a while. I also tried setting up an external Docker host to act as my Docker machine so that each ephemeral Jenkins agent simply had to mount the socket, had to mount the socket of the external Docker host. And then finally, I used the EC2 plugin and I dynamically generated EC2 Docker hosts that all had the Docker machine running and then allowed those to spin up agents. So I tried many different things before finally getting to the point of deciding to try Kubernetes. So that's what we're going to talk about today. I'm going to talk you through what I learned in running Jenkins and Kubernetes for the first time and hopefully give you the building blocks that you need to be able to try this yourself. So before we jump into running Jenkins and Kubernetes, I just want to take a moment and kind of give you a quick overview of the concepts of running in Kubernetes, because these were concepts that I wasn't as familiar with when I got started, and understanding them really helped. So the first thing is a node. In Kubernetes, a node is a physical or a virtual machine that runs all of the components that make up the Kubernetes platform. We're going to be running more than one of those nodes together, and that is known as a cluster. So we've got one or more nodes running together to share the workload, running all of the individual components of Kubernetes to serve our application, or in this case, run our Jenkins master and agents. The next piece is the concept of a pod. Pause. The next piece of this is the concept of a pod. A pod consists of one or more containers that live and die together. So if you've ever run, say, Docker Compose and you've got services that interact together, that's a similar concept to running a pod in Kubernetes. You might have a single, your database instance, your application instance, and then when you want to scale, you can create individual pods of that set of containers that make up your application. The next concept is a service. So a service is an abstraction that allows your application to be accessible externally. So this is how you're going to provide access to a web application, is by creating a service so that you can expose that and define which ports are available and that sort of thing. So these are very minimum basic concepts of Kubernetes. So the next thing I wanted to talk about is the concept of Helm charts. Helm is the package manager for Kubernetes. If you consider, say if you've run APK or any of the other Linux package managers, or say you're running Chocolatey on Windows, it's the same idea, but it's for Kubernetes applications. And a Helm chart packages the application in a particular way where the Helm executable knows how to install that application and configure it within Kubernetes. So to walk you through the parts of a Helm chart and kind of help you understand how Helm charts are used to install applications in Kubernetes, I'd like to jump over to the repository that contains the Helm chart for Jenkins. So if you're already familiar with Kubernetes, then some of these configuration files will probably look very familiar. You've got a bunch of YAML with variable substitutions. So if you're already familiar with running Kubernetes, then this looks very familiar, I'm pretty sure. And these are all configurable. We pass values at runtime via a values.yaml, and I want to show you just how configurable and extensible it is to run Jenkins and Kubernetes. You have a wide range of control over the configuration of Jenkins. Now, if you're looking at this and you're thinking, wow, that's great, I have a lot of control, I love this, that's fantastic. But if you're looking at this thinking, wow, that's a lot of configuration, that is super overwhelming and I don't know where to start, don't worry. The great thing about Helm charts is that for all of this configuration, the Helm chart itself provides a lot of sane defaults, so that if you don't particularly care about fine-tuning at that level, that's not a problem. You'll have defaults available so that you can only configure what matters to you. So for the Jenkins Helm chart, I followed a tutorial from GKE written by Victor Iglesias. I recommend all of his tutorials. They're very, very useful, very detailed, and very easy to read. And it provided a sample values.yaml with the things that I would want to override when deploying Jenkins to Kubernetes in GKE. So this is the minimum set I needed to actually override. So if you consider the very long values.yaml that I showed you in GitHub, which was, understandably a bit overwhelming, don't worry. These are the only values I had to actually update, and the tutorial walks you through all of those. So it's very simple, and you really don't have to understand the ins and outs of Helm or all the values to get started. So before I could install via Helm, there were a few things that I needed to do. I'm not going to go into the details of these particular pieces, but I need you to know that it is very simple to do, and I've got a resources slide that will link you to the tutorials that I found useful, and they give you everything you need to set up your Kubernetes cluster to get ready to install Jenkins. So I needed a compute engine network, a Kubernetes cluster, which, as we said, it consists of one or more nodes, which are physical or virtual machines running the Kubernetes components. Within my Kubernetes cluster, I need Helm installed so that I can use a Helm chart to install Jenkins. I need to set up some access in the cluster, and then grant admin access to Tiller, which is the server side of Helm. Then there's a little bit of initialization that's required, and then we're ready to install Jenkins. So if you already have a functional Kubernetes cluster, if you're already familiar with Kubernetes and all you need to do is understand how to run Jenkins in Kubernetes, then you're already set up. If you don't, I will point you to all of the resources you need to get you to this point so that you can pick up from my slides and be ready to go. So once I have my Kubernetes cluster ready, the next thing I do is I'm going to install Jenkins using Helm. And I simply do a Helm install, point it to the stable Jenkins chart that I want to use, and it's going to deploy my Jenkins master directly into my Kubernetes cluster. So once you have Jenkins running, at this point we've got a Jenkins master, but it's not ready for continuous integration and deployment. We're going to need to do a few things. I'm going to show you how to do those. You're going to need to configure your credential sets for Kubernetes, for the Kubernetes cluster, so that your Jenkins master has authority to launch build agents in the same cluster. You'll need to create a cloud configuration for the Kubernetes cluster so that the Jenkins master knows where to launch the build agents in Kubernetes. Then we'll create a pod template for the agent. And remember that a pod is a set of containers that lives and dies together. In this case, we can launch a pod of any of the types of agents we need for building. And the last thing is we're going to create a container template for the agent. So that's an overview of what we're going to do. Now let's look at how that is configured in Jenkins. So the first thing is the Kubernetes service account. If you follow the suggested tutorial and you provide the values.yaml from the sample in my slide deck, there's really nothing to configure. That is all configured out of the box using that particular Helm chart with that particular set of values.yaml. But you're going to need a credential set to refer to so that when Jenkins will know, Jenkins will have authority to launch the new agents. The next thing is you're going to need to configure the Kubernetes cloud that you wish to use so that the Jenkins master knows where to launch those agents. But again, using the Helm chart and the values.yaml, this is pre-configured and you actually don't have to enter these values manually. It will be ready to go. The next piece is configuring a pod template. So if you've ever written a pipeline script and referred to a particular agent, whether it was an EC2 instance or another physical server, you define agents by name. And this is exactly what we're doing here. We're configuring a pod that represents our Jenkins agent. Just like with your traditional Jenkins agents, you can define, I'm saying that I only want to build jobs with the labels when I specify that I want to build on the node matching this label, which I've called test agent. And you can configure anything from individual containers, which we'll get to in the next slide, to environment variables that you want to make available in the agent. Say if you want to have some of the environment variables set on the master pass through to the agent, you can define that here. You can mount volumes and really have a lot of control over how those agents are configured. So within a particular pod, as I stated, we're going to have a pod consisting of one or more containers. And if I want to build a Go application within my pod that I'm going to refer to in my pipeline scripts, I'm going to need certain containers for the actual work that I'm going to be doing in my pipeline script. So here, if you go back, this is just an expansion of clicking this button, and it gives you this additional dialog box to enter the details for your container. So here I'm indicating a name, Golang. That's how I'm going to refer to this particular container in my pipeline scripts. I'm specifying the Docker image that I want to use, giving it the working directory. And again, I can pass environment variables and have a lot of control over how this container is run. So we set up credentials so that the Jenkins master has access to the Kubernetes cluster. We've configured the Kubernetes cloud definition so that the Jenkins master knows where to launch agents in Kubernetes. And we've configured a pod template indicating the name of the set of containers we want to refer to in a pipeline script. And then we add to that pod the individual containers that we would like to have available when we use that pod as a Jenkins agent. How do you use it? In the Jenkins file, of course. Here we specify at the top level a node, which is our I think I called it test pod in the screenshot, but I like calling it super pod because it can do pretty much anything I need it to do. So you refer to your node just like you do with your EC2 instances or your physical server nodes, you just give it by label. I'm indicating I want to run this Jenkins file on the node supernode, and that's going to cause the Jenkins master to launch a pod in the Kubernetes environment specified using the definition that we defined in the UI before. And then you just run all the steps you would normally run. You do your checkout, you can use your plugin syntax, create stages, and then once I get down here to the build stage, that's where I'm going to specify that Golang container. If I want to build an application and run tests for a Go application, I'm going to want to perform those particular steps within my Golang container because it contains all of the tool chain I need to do that. So once we run a build, once we start a new build, we will see pods running. We see the first pod, the CD Jenkins pod, is the Jenkins master running. And then once a build is running and Jenkins master launches an agent to perform the work, you can see you also have that super pod running. So I've got two snippets here. I've got one build. You can see the super pod name. And then when I run a build later, you see a different super pod name. This is because these agents are being launched ephemerally. Now to take a step back, that's because that's the way I defined it. I wanted to minimize resource usage, and I only wanted to launch the pod when I needed it. As with any ephemeral Jenkins agents, you have some control where you can ask it to, say, wait 15 minutes for another build. So if you're building similar applications in succession, you don't have to incur the cost of launching a new pod every time. That's a possibility, but I wanted to show you how every time you run a build, when you configure it this way, you can get a brand new agent every time so that when you're not running builds, you're not incurring the cost of running those pods. So now we're running our builds in Kubernetes. The agent is running in a pod and has access to the containers that we built. So I wanted to show you an even better way to configure this. I personally don't love using the UI. I like everything to be codified and checked into source control so that if something happens to my Jenkins environment, I have my configuration for my actual build stored somewhere. So remember in the UI, we defined a pod template. You can do all of this directly in your Jenkins file. So here I've got the pod template definition with test pod. I've given it a label. Here I'm defining the containers I want to run in here. One of the things I wanted to note, there were a lot of configuration options in the UI, and you can include all of those configuration options directly in your Jenkins file within this pod template definition, within the container template definition. Everything you could do through the UI, you can do right here in your Jenkins file. So in this example, I've got a Go application that I'm going to build, and once I have the binary, I want to build a Docker image. So in this pod, I'm including a Golang container, and also I am including a container that includes a Docker client that I, here in the volume section, I'm able to mount the socket of my locally running Docker host so that I can then use these steps here to build a container. So taking a step back, before running in Kubernetes, the way in which I built my applications was I built a binary and then I use Docker commands directly to build the image. So I really wanted to ensure that I could replicate building in the way that I was already familiar so that I could do a one-to-one comparison. So in this example, I have my Docker client here to build my images. But in this next slide, you can also use GCloud and all of the GCloud tools if you're familiar with that, or any of the other cloud providers that provide tool sets for using a CLI to build and push your Docker containers. You can simply substitute the Docker client container with one that includes your cloud provider's CLI. So you can use all of the steps that you're familiar with if you've run those commands from your local machine to build and push Docker images. So this is what your Jenkins file looks like. Everything you need is contained here. You may use the UI, and I think it's a really great way when you're getting started because this can be a bit overwhelming. And you can use these as examples, but feel free to get started by configuring in the UI, and as you get more confident with the different options, then you can put everything in your Jenkins file so that it's all backed up in GitHub and you don't have to worry about, someone changing your configuration in Jenkins or, having a disaster recovery type of scenario with your actual build instructions. So the final thing I want to show you is you can actually do all of the UI work we did directly in your Jenkins file, especially if you're already familiar with defining things using YAML. This is a short snippet where you can do it all in YAML and keep that same syntax. If you're already familiar with Kubernetes, you can use that syntax directly within your Jenkins file so that everything, excuse me, you can use the exact same syntax that you're already familiar with directly in your Jenkins file so that everything is contained here. So let's take a moment and talk through what we've done. The way we're building software has changed, and the way we run our continuous integration and continuous deployment environments using Jenkins has to change to match that. If we are going to keep up with all the promises of microservices, of frequent, individual, small releases, we are going to need a Jenkins environment that can keep up with that load and that can scale with that load. So you should constantly be keeping up with what Jenkins is doing to keep up with the way we build software so that you can take advantage of all the capabilities that Jenkins has available. Jenkins and CloudBees is doing a really great job of staying in front of that curve and having offerings to do all sorts of things and take advantage of the different technologies that are available. So you definitely want to benefit from all of the work that the Jenkins community is doing. I also want to tell you that you can spin up a Jenkins environment in Kubernetes. When I put this together, I presented this at Jenkins World last year, and I really was interested in Kubernetes and all of the tutorials I read, especially the documentation. It was just not interesting. It was hard to grasp, but Jenkins is interesting. CI/CD is interesting. So I had never used Kubernetes before when I began preparing for this presentation, and I got everything running in a weekend following the instructions in the tutorials. Let me take that back. I got it running in a couple of hours. It was that simple, but then it took the better part of the weekend to then take a step back and understand the core concepts of what I had done to get that running. So I definitely recommend that you not bog yourself down with understanding all of the ins and outs of Kubernetes. Once you get it running, it's just you have a lot more context to understand what you've done. So you too can spin up a Jenkins environment in Kubernetes. It's simple to do. There are lots of resources available. So what are your questions? What did we not cover? Once you get started, if you have questions or problems or something isn't working, find me on Twitter or LinkedIn. Come by and say hi. Let me know how you found me. And whatever problems you encounter, I'd love to look into solving them with you, because every time I work with someone to help solve a new problem that I haven't encountered, it's just another opportunity for me to learn more about running Jenkins in different ways. So thank you for coming to this presentation today. I'll be available for questions after the webinar, so use the chat tool in the application if you have questions now. If you have questions later, here's where you find me. Thanks so much.